Assalamualaikum dear students. This is our next problem. Problem once again having been chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. A photon of wavelength 192 nanometer, nano 10 to power minus 9. A photon of wavelength 192 nanometers strikes an aluminum surface along a line perpendicular to the surface and releases a photoelectron traveling in the opposite direction. Assume the recoil momentum is taken up by a single aluminum atom on the surface. Calculate the recoil kinetic energy of the atom. Would this recoil energy significantly affect the kinetic energy of the photoelectron? Dear students, in this problem we will have to visit several tables, several helping tools. Okay, so this problem is not so simple. We are now gradually moving towards relatively harder problems. Okay, anyhow, we first come towards helping tools and then we will discuss solution of this problem. Okay, dear students, first helping tool is that helping tool which has been chosen or taken many times. Okay, many times during our previous problems. Tool is quite simple, in which momentum of a photon is defined. Momentum of a photon denoted by P is equal to E over C, where E is the photon energy and C is the speed of light in vacuum. This expression alternatively becomes equal to HF over C, where H is the Planck's constant and F is the frequency. This expression in the third stage alternatively becomes equal to H over lambda, where lambda is the wavelength. We know that frequency and wavelength are inversely related with the involvement of speed of light c. Okay, now we come towards tool number 2. This tool has also been chosen or selected so many times that it is almost less important to discuss this tool in detail. Okay, dear students, in this, from this table we will take this value. Okay, 0.511 million electron volt. Okay, some masses in energy units. In place of mc square we will take 511,000 electron volt. Okay, or we can also take it in the same way, in million electron volt. Okay, in tool number 3, this tool has again been used or taken several times in our previous problems. In this tool we are concerned with the value of aluminum. Okay, what? Aluminum at second second row. Okay, aluminum having photoelectric work function 4.08. Okay, photoelectric work function denoted by phi is 4.08 for aluminum. Okay, Tool number 4, this tool has also been taken several times in our previous problems. Okay, so we do not waste time on considering this. Okay, discussing this. Okay, here what is important, yes, dear students, in this problem we will take this value, speed of light c 2.998 into 10 to power 8 meter per second. We will take Planck's constant, okay, which is given in two equivalent systems. Okay, moreover we will take electron mass 0.511 million electron volt over c square. Okay, moreover we may also take the combined effect of h and c, Planck's constant and speed of light. Okay, moreover one atomic mass unit is equal to 931.5 million electron volt over c square. Okay, this expression is very, very important in this problem. Okay, anyhow, now we move to next tool number 5. There is nothing in this nothing new in this tool. Almost all things have been covered previously. Okay, however the only difference is that here not only the value of c is given 2.998 into 10 to power 8 meter per second, but also value of c square mass energy relation is also given in terms of atomic mass unit. Okay, 931.49 million electron volt over u, and 1 u 931.5 million electron volt over c square. Okay, okay. Clear, students? Not only the value of c but also the value of c square. The value of c square is given from here. Okay, this c square on being shifted to other side of the equality will become in the numerator. Okay, and this u, atomic mass unit, which is in the numerator on left side, will become in the denominator after being transferred on other side of equality. Okay, moreover nothing new. Planck's constant, no, almost same. Dear students, the same table has also been reproduced in a slightly different manner from some other book. Okay, this snapshot has been selected from other book, and here again almost all those things are included which we have discussed previously. Okay, however it is just an introduction that various books include such tables in a slightly different manner. Okay, here once again same thing has been repeated from some other book, in which atomic mass unit u is given as this 931.494028 million electron volt per c square. Okay, now we come towards tool number 6. Dear students, tool number 6 deals with various elements. Okay, in this tool all elements are not shown. Actually such a table is usually very lengthy, comprising several pages. I have selected just starting mode, this shape, that is element, symbol, atomic number Z, molar gas, gram per mole. Okay, here in the second row aluminum Al is given, whose atomic number Z is 13 and whose molar gas G per mole is 26.9815. We are concerned with this value. Okay, However, we will repeat similar table from various books just in order to have some acquaintance or familiarity with this thing. Okay, this snapshot has been selected from some other book. Okay, almost same material, atomic number, names, symbol, atomic weight. Okay, here at CDL number 13, aluminum Al, atomic weight 26.981539. Okay, next, same thing, snapshot having been chosen from some other book. Okay, here what is given? Here Z is given, N is given. Okay, atomic mass unit is given. Anyhow, we come towards aluminum. Yes, this is second last and last. Okay, this is aluminum. Its atomic mass unit, it is 25.986891, but we will not take this. We will take second value. Okay, 26.981538.4. Now we show some other snapshots. Okay, in other snapshot, this is actually upper portion only, in which it is shown in which pattern this table starts. Okay, atomic number Z, element, symbol, mass number A, atomic mass U. Okay, in the remaining part, this is okay. Yes, this is the remaining part of this table, in which aluminum 13, aluminum Al 27, 26.981541. Okay, we will choose this value. Okay, 26.981. Okay, similarly, another snapshot from some other book, atomic number, name, symbol, mass. Here again 13, aluminum Al 26.981538.6. Similarly, another snapshot, atomic number Z, element, symbol, mass number A, atomic mass U. Okay, this is starting portion of that table, and this is the actual concerned portion of that table, in which 13, aluminum Al 27, 26.981539. Okay, it is quite enough. Dear students, we can take snapshot of such tables from hundreds book, but only one is quite sufficient. It was just as a practice. Okay, now we come towards its solution. Okay, we know that momentum P is equal to E over C is equal to HF over C is equal to H over lambda. Okay, we have done, we have taken the value of H from table, Planck's constant. We have taken the value of lambda, which is provided in the statement, which is 192 nanometer. Okay, nano means 10 to power minus 9 meter. So when we will put this value and simplify, we will get the result 6.458 electron volt per C. Okay, okay, yes. Now we move to next part. Okay, now momentum P is equal to E over C. This implies that E is equal to PC. This is equal to P into C. What we have done, we have taken the value of P, which we have calculated in previous step. Okay, this is this. Okay, 6.458, 6.458, 6.458. Okay, what we have done, we have simply put the value of P, which we have calculated in previous step, and we have multiplied it with C, which is a part of expression, part of definition, part of equation. Okay, C will be cancelled with C and we will be left with 6.458 electron volt. This is energy. Okay. Energy E has become equal to 6.458 electron volt. The only difference in previous and this is that previous was momentum and momentum was in terms of electron volt per C, while this is energy and this is in shape of electron volt only. Okay. Now we know that maximum kinetic energy of photoelectrons is given by K max is equal to E into Vs, stopping potential Vs. This again by definition is equal to Hf minus phi work function. Okay. Planck's constant into frequency minus work function phi. This alternatively becomes equal to Hc over wavelength lambda minus work function phi, where Vs is the stopping potential. This implies that K max is equal to Hc over lambda minus phi. Okay. So in the next step, what we have done? We have done put the value of Hc. What we have done? We have taken the combined value of Hc, which is also given in the table. Okay, in the table, which we did not show one table, we showed a number of tables. Okay, in these number of tables, not only the value of H and C are given separately, but also after multiplying both these their combined result is also shown. Okay, so we have here used directly the combined result of these two quantities. Okay, yes. So maximum kinetic energy K max has become equal to value of Hc taken from the table divided by value of wavelength lambda, which is given in the statement, minus in place of work function phi we have used its value, which is again given in the table which has been shown in helping tools. Okay, from helping tool table we have taken the value of work function phi for aluminum. Okay, work function phi for aluminum is 4.08 electron volt. So dear students, here meter will be cancelled with meter and we will be left with this result, and after simplification we will get K max, maximum kinetic energy, equal to 2.378 electron volt. Okay, yes. Also dear students, these are two expressions. Okay, kinetic energy equal to half mv square and momentum is equal to mv. Okay, these are two classical expressions. Okay, classical expressions, not relativistic. Classical expressions. From here the combined effect of these two expressions takes the form as k equal to p square over 2m. This implies that if we keep p square on one side, then it becomes equal to 2mk. Moreover, if we multiply both sides with c square, then it becomes p square c square equal to 2m c square k. What we have done? We have multiplied with c square on both sides. Okay, so p square c square becomes equal to 2 into, in place of mc square we have used our helping tool, in which value of electron, in case of electron, value of mc square has been given as 0.511 million electron volt, and value of k we have determined in the previous step. Okay, so what we have done, we have just put the relevant values, otherwise we have done nothing. Okay, so dear students, here p square c square becomes equal to, after simplifying, 2430316 electron volt square. Okay, yes. Now what we will do, we will do that we will take under root on both sides, because we have to determine the value of PC, okay, not P square C square. So when we will take under root on both sides, then square of electron volt will vanish and it will become simply electron volt. Moreover, under root of 2430316 will become equal to 1558.947 electron volt, and hence from here P becomes equal to that value divided by C. Okay, so P becomes equal to 1558.947 electron volt over C. Okay, now we move further. Okay, according to law of conservation of momentum, momentum of atom is equal to momentum of photon plus momentum of electron. Is there any doubt in this step? I think there should be no doubt. Momentum of atom is equal to momentum of photon plus momentum of electron. Momentum of photon we have calculated in previous step, and momentum of electron we have also calculated in previous step. So both are given and we are just going to add these two quantities. Then momentum of atom will become 1565.405 electron volt over C. Okay, I think we should now move further. Now once again, two relativistic expressions, kinetic energy equal to half mv square and momentum P equal to mv, implies that K becomes equal to P square over 2m. This implies that K is equal to P square over 2m. What we can do, we can multiply and divide it with C square. Okay, there will be no difference. But our purpose will be solved and a clear picture will appear before us so that we may proceed towards our required solution. Okay, by dividing and multiplying it with C square, we have got K equal to P square C square over 2mc square. This implies that now we are taking into consideration kinetic energy of atom. Previously we had done it for photon. Okay, now so kinetic energy of atom becomes equal to photon momentum of atom square into C square over 2mc square. Okay, this implies that kinetic energy of atom becomes equal to, we have already calculated momentum of atom in the previous step. Okay, so we have just put its value. Moreover, we have not done anything with C square. C square is quite as it was divided and multiplied. Okay, in the numerator we have not touched C square, it is quite as it is, but in the denominator we have taken its value from helping tool. Okay, so K atom becomes equal to, we have used the value of momentum of atom whole square into C square divided by 2 into 26.9815 U atomic mass unit. Okay, dear students, this is that value for which we have shown a large number of tables in which atomic number, atomic mass, Z, etc. were given. Okay, we had just first shown starting mode of that table, and then we had taken a few lines in which aluminum was involved. Okay, otherwise such tables are very lengthy. such tables consist of several pages. So I had exercised practice that I just took a snapshot of starting portion of that table and then a few lines in which aluminum was included. Okay, so in place of m we have used this value, and in place of c square we have used this value. This value is also given in many tables, and I have pointed out that c square is equal to this. Okay, I think it should be clear. In case of any doubt, you can watch this video slowly and as you like. Okay, I have done my work quite satisfactorily as per my understanding. Okay, so kinetic energy of atom becomes equal to this over this, this over this, this over this, and it becomes equal to 4.875 into 10 to power minus 5 electron volt. Okay, our result has almost appeared. Now we compare it with dear students, these three dots in which third dot is below two parallel dots. This symbol denotes that because or since this value, that is 4.8 into 10 to the minus 5 electron volt, is very less than 511,000 electron volt. Okay, this value is given in many tables, okay, which I have shown in this video in this problem. Okay, since this value is very less than this value, therefore this symbol in which third dot is above two parallel dots denotes therefore. Okay, because this value is very less than this value, therefore atom can take the recoil momentum easily at little cost in energy. This is the final opinion about the our so dear students, this is the end of our problem. Okay.